All right. So here we go, ladies and gentlemen. We're doing chapter 12, arithmetic sequences. Kind of talked about this the other day. If you look, these are examples of arithmetic sequences. Okay, 2, 4, 6, 8. Who do we appreciate? What we have there is consecutive numbers in the sequence all have a common difference. We call that D. And what do you guys notice it keeps going up by? What do we keep adding to get the next number in the sequence? We keep adding 2. So we would say our D value, our common difference is 2. Okay? When I look at another sequence, 9, 6, 3, 0, negative 3, we notice it keeps going down by a certain amount. What does it keep going down by? By 3. So that would be a negative 3 for your common difference. So if it's going up, it's positive. If it's going down, it's negative. Okay? Now, if you're not able to look at that sequence and identify what's going on, you guys could always use this basic idea where you take the second term and you subtract the first term, or you take the third term and subtract the second term, or so on and so forth. So if you ever need the D value and it's not very clear, which most of the time it is, you could always take the second and subtract the first. So if I take 6 minus 9, I get negative 3 there. Or if I take 4 minus 2, I get 2. Okay? So you guys should be able to do goal number 1 very easily, just be able to determine if a sequence is arithmetic. You should be able to see that it keeps going up by the same amount every time or going down by the same amount. Goal number 2 and 3 says find the formula of an arithmetic sequence. We're going to deal with that here in a minute. And then we'll talk at the very end about the sum of an arithmetic sequence. We're going to talk about how to do that. So as we take a look, it says an arithmetic sequence may be defined recursively as this. A sub 1, we talked about, is our first term. Now, every once in a while, you may see where they just state A. So if you ever just see A, then you need to know that is the same thing as A sub 1. They're equivalent, okay? Just like when we see 1x, we don't ever write 1x, it's just x. Or we don't write x to the first power, it's just x, and it's assumed that it's a 1 up there. Same idea with subscript. If you don't see subscript down here, then we know it's a 1, it's the first term, okay? This part of what's called recursive formula, this part, a sub n equals a sub n minus 1 plus d, is just saying, hey, if you want the number in the sequence, take the number in front of it and add the difference. So, for example, if I want the next number in my sequence, I take 8 and I add my d value, 2. So 8 plus 2 is 10, plus 2 is 12, plus 2 is 14. That's what that recursive formula means. Okay, don't worry too much about that, though. All right, any questions so far? All right, here comes the good stuff, guys. It says here an arithmetic sequence with the first term A and common difference D follows this pattern. This A is my first term. Then I add D to it, so I get my second term is A plus D, so that's my second. Well, then I add D to that. So A plus D or A plus 2D is my third term. And then I add D to that again. Now I got, for my fourth term, A plus 3D. So what you notice is that for each term, the number in front of D is always 1 less than what term it is. So the formula that they derived and they came up with was A sub n equals A, your first term, plus n minus 1 times D. Okay, so it's always 1 less than what term you're at. This is a very important formula, so I boxed it up, I've highlighted, I'm putting stars next to it. Quiz or test, if this was non-COVID time, I would give you a formula sheet that had it on there, or you would have your own little note card. All right, it's a pretty important formula, you got to use it, okay? Now, I wouldn't make you memorize it, you just need to know how to use it and when to use it. So, this is, again, your formula for your sequence, your arithmetic sequence. You might hear me say this is the nth term formula. So my nth term, so anytime I need to find an nth term or any term, I can use that formula, okay? So we'll come back to that here on the next page. So let's go through, and when you guys are doing your homework on my math lab, I know that it's like 12 questions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But in the left-hand corner, after you click on that, it will say what section it's from. And then there's a number that corresponds with the number in the actual textbook. So you might see like 12.2 number 7 or 12.2 number 9 or what have you. Well, any of those numbers between 7 and 16 is this type of question. So this is different kind of math, guys. This is not what you're used to. So I'm trying to do my best to kind of help you work your way through. So use these notes as you're going through. All right, your homework and stuff is going to help you. So this question says, take this arithmetic sequence that's given and find the common difference. So we need to find D, and then write out the first 4 terms. Well, we did that in chapter 12.1. If we want to find the first term, we take our sequence 3n plus 5 and we plug in what? Plug in 1. 3 times 1 plus 5 we know is 8. And then plug in 2. 3 times 2 plus 5, 6 plus 5 is 11. And then you can plug in 3 and plug in 4. Or, once you have the first 2 terms, it should be pretty clear on what your common difference is, right? If you need that formula again, take the second and subtract the first. If I take 11 and I subtract 8, I get a common difference of what, 3? So you can see that it goes up by 3 now, so keep on adding 3. 8 plus 3 is 11, plus 3 is 14, plus 3 is 17. So I have my first 4 terms in my sequence, and I have my common difference. Okay? Any questions for me with regards to example 1 on how I'm doing that? So again, you can plug in 1, plug in 2, plug in 3, plug in 4, or find the first 2, find the difference, and then keep on adding that. Okay? Give me a thumb, guys. Where are we at? Thumb. Do we need to see example 2, y'all? Say skip it, skip, or see example 2. What do you guys want to do? Oh, man, we got a lot of no cameras today. Holy cow. Skip it. What do you guys want? Skip it? We're okay? All right, so very similar. Just plug in 1, 2, 3, 4, and then you have your common difference. So I'm going to go ahead and skip number 2. I don't want to waste your time here, y'all. And then let's dive into this nth term formula stuff. Okay? So if I look on the very top, there it is. That's my buddy right there. I'm going to highlight it again. I want my formula right there. I'm going to put it in a box. I've got it starred up. Pretty important. So when I look at our homework tonight, if you're going through and you got a problem like 17 through 24 in that left-hand corner, it says find the nth term of an arithmetic sequence. So we're going to use our nth term formula, whose initial term A and D are given, and then what's the 5th term? So there's 2 things I got to do, guys. I got to find A sub n, and then I got to find that 5th term there. That 5th term is A sub 5. Well, the first thing we got to do is find our nth term. So nth term. I use my nth term formula. I've got A sub n equals A plus n minus 1 times D. If they want me to find the nth term, it's going to have an n in it. And we just plug in our A and D value. So our A value is 2 plus n minus 1 times D, which is 4. And we're going to simplify, and we should get an answer that looks very similar to where we started with example 1, which I think was like 3n plus 5. So we go ahead and distribute. We get 2. 4 times n is 4n. 4 times 1 is negative 4. And then we simplify that. And we get 2 minus 4 is negative 2. Okay, so if they want my nth term, this is my nth term. Now the next question is, what's the fifth term? So we got a sub 5. We're going to take 4 times 5 and then subtract 2. So this is an awesome formula. It allows me to find any term I want. If I want the first, plug in 1. If I want the second, plug in 2. If I want the fifth term, plug in 5. And we get what? 20 minus 2. Please excuse your dear Aunt Sally's as you're doing it. So we get a sub 5 is what? 18. Good stuff. Any questions, y'all? Do you feel like we need to see example 4, which is just like example number 3? We're okay with that? I don't want to waste our time today. Guys at home, are you guys okay with us? Any questions? Is Andrew shaking his head? Yes? No questions? Oh man, a lot of no cameras on. Oh man, hope you got this. I'm going to move on then.
I understand.
Thanks. Was that Jackson that said that? It sounded like a girl. All right, so when I take a look at this next one, I got 25 to 30. When you're doing problems 25 to 30, very similar, okay? Now, the nice thing is example 5 and 6 is very similar to 3 and 4. They want us to find the indicated term here. In this case, they want us to find a sub 13. They want us to find the 13th term. Okay, that's what they want. But they don't blatantly say, hey, Mr. Gotch. They don't say, hey, Emily. They don't say, hey, A is this and D is this. We have to look at the sequence and identify our A value and our D value. So for us to find A sub 13, we need to know N, which is the 13th term, which is 13. And we need to know A and we need to know D. Shout it out. What do you guys got for the first term? A of 2, 6, 10, 14, 18, ... Shout it out online. Shout it out in class. 2. Boom. And then D, 4. So we can see that this thing keeps going up by 4, right? Good. Paige, is that what you're going to say? 2 and 4?
No, I just was looking at the wrong question.
Oh. Are you okay, though, where we're at now?
I'm good. I was just confused.
Okay. So we got A is 2 and D is 4, and I'm going to use that A sub n formula again. I'm getting that from up there, the highlighted thing. So I got A is 2. I've got n minus 1, so n is 13 minus 1, and then times D, which is 4. So we got 13 minus 1, we know is 12. Please excuse my dear Aunt Sally as we're doing this. That's 2. 12 times 4 we know is 48. So we end up with our 13th term is what, 50? Okay. Now every year I get that one person like, well, Mr. Gotsch, can I just keep on adding my difference over and over and over to get to that 13th term? And the answer is yes. But what would you do if that's the 100th term? Are you going to do that 100 times? What if it's the 1,000th term? Are you going to do that 1,000 times? Oh my gosh, please don't do it. Just do the formula. It's way easier. It doesn't take very long.
A is where you start, right?
Yep, A is your first term. Yep, very good. So the question is the A value your first term where you start? And that is yes. And D, what we keep going up by. Very good. So again, get used to the formula and know how to use it, because not always is it the 13th term or very close to where we start. Sometimes it might be the 270th term. So we want to be able to do this quickly and efficiently. That's where the formula comes in. Do you guys feel like we need a C number 6? We okay with that? All right, all right. So I'm going to skip number 6. It's very similar. And now I get to the tougher one. Here we go. This is where this is a little bit tougher. Okay? When you're doing your homework, 31 through 38 is what I'm looking at here. Okay? So when I take a look, it says find the first term. So that's A, find A. And the common difference. So we got to find D. Of the arithmetic sequence described, and at the end we'll give what's called a recursive formula. I'll explain what that is again. Super easy. So we need two things. We need A and D. Okay? Now look at what they gave us this time. They didn't give us the sequence like they did up here where it's 2, 6, 10, 14, 18, They give us just that the 8th term is 4 and the 18th term is negative 96. Right? So this is where I go, what in the world's going on? Let me put this into an easier sequence so we understand how and what I'm going to do here. Okay? Because it's no fun, especially if I just tell you the answers and then you just regurgitate. I like to have you kind of understand what's going on. So let's go back to an easy sequence that we started with today. 2, 4, 6, 8. Who do we appreciate? We all identified that the difference is what? 2. That's easy, right? When you give me a big sequence of numbers, it's super easy to identify. But what if I said, okay, I'm only going to give you this guy, and I'm only going to give you this guy, and I'm going to tell you that this is the 3rd number, and this is the 5th number in the sequence, but I didn't tell you this, and I didn't tell you this, and I didn't tell you this. Now, we know, right? We know what that D value is because we know what the sequence is, but what if we didn't know the sequence? How do we get this to turn into a 2? How do we know the difference of this thing is 2 here, given this sequence? That we have the 3rd term is 6 and the 5th term is 10. How do we get 2 out of that? This is where we just put our brainstorming caps on, okay? And we throw out some ideas. Melissa, what do you got?
Would you just substitute what you have into the formula?
Substitute. So the formula that I think you're thinking of is this guy. Like before it was a sub 2 minus a sub 1. Is that what you're thinking?
No, I don't know what it's called.
The a sub n formula?
Yes.
We're going to use that eventually to find a, but how do we use this information to find d? Is my question. Okay, so eventually we are going to use that formula. But think about how we did difference before. We took the 2nd term and subtract the 1st term, right? Now, how can we apply this idea to this problem now? Is my question. Suggestions. What's that?
Would it be like the places that, like, so how it's the 3rd and 5th term, there's 2 in between, or like 2 places in between?
Okay.
Would that?
So the position of where this thing is important, right? This is the 3rd term, 5th term. We know that's 2 spots away from each other, right? We're going to use that idea. How are we going to use that?
Put it in front of the d in the equation. D equals a2 minus a1.
Say that again. You kind of tailed off at the end.
Sorry, I was saying put that number in front of the d in the d equals a2 minus a1 equation.
Okay, so that's like a 2D here. Is that what you're saying?
Yeah.
Okay, so that's kind of the idea, all right? If you subtract these two, this is kind of where we're leading here, and Kaylee's kind of got us on the right track. If I subtract these two, like we normally would, right? If I do 10 minus 6, you all agree that's only 4. Well, that's not 2. So what do we have to do to turn that into a 2? And Kaylee was saying use the position of where these guys are, the difference between these two, right? So if you do 5 minus 3 here, you agree that's 2. And 4 divided by 2, you guys get is 2. Does that make sense? Now let's see if that works again. Let's say I have 2, 4, 6, 8, 10, 12, and 14. Let's say I have the second term, and that term is what? 2, 3, 4, 5, 6, 7, the seventh term. And we didn't have these other terms. Let's just see if that works again. Just problem solving, right? If I set up my difference, 14 minus 4, big one minus little one, that's 10. And then set, oh, look at that, 7 minus 2 is 5. It works out perfect. Perfect. Well, now we want to have an understanding, why does that work, right? So excellent job, you guys. Kaylee, nice job. If I look at these two, this looks very similar to something we've seen back in the day, back in Algebra 1, back in Algebra 2, back in Geom. Paige, you got any?
Yeah, I have a question.
Yep.
Can we just assume that they're always equally spaced apart all the way down?
Yes.
Okay.
Question is, can we always assume they're equally spaced? And the answer is yes, they're always going to have the same D value going across for each term. So my question now is, again, is this looks like something I've seen before. You guys done it 1,000 times now. What does this and this guy look like? Say it again. Yeah, these guys are slope. Okay, now my question is, why is it slope? Okay, well, let's take a look at a graph. Let me see if I got some graph here. Some graph paper. Slope. Mr. God, nobody said anything. I wrote slop. Oh my gosh. You guys let me do that? Well, let's take a look at that sequence. We agree that the first term is 2. So if I go over 1, I go up 2. That's the first term is 2. What's the second term? Second term is 4. Look at that. The third term we said was 6. Look at that. The fourth term, you see what I'm making here? Fifth term, 10. You guys see? Mind blown? Yes? And our arithmetic sequence is plotted to create a line. Oh my gosh. And that slope, guys, right? That slope, this guy right here, is your D value. So that's why that all works out. Okay? So nice work. That's why this works. Arithmetic sequences is slope, baby. All right. So, here we go. So we're going to find our D value using this idea of slope. We're going to take one of the terms and subtract the other one. And then we're going to divide it by the position they are in the sequence. Okay? So again, think slope. So remember, slope back in the day, picnic table, margarita glasses, yeah? 21 to drink legally. Not 12, that would be silly. Well, the 8th term is 4. You could think of that as a corner point, 8 comma 4. And the 18th term is negative 96. Well, that's like 18 comma negative 96 if you want to think it as a point. And then use that idea to plug it in. Okay, so A sub n is one of the terms. It's negative 96. Minus the other term, which is 4. And then I divide it by what term is negative 96? Negative 96 is the 18th term. And then what term is 4? 4 is the 8th term. So I do a little simplifying. I get negative 100 over 10. So we get a common difference of what? Negative 10? Look at that. Okay. Once you get an understanding of what you're doing, I think it helps you be able to do it, right? So that's why it took you 5 minutes to come up with that slope idea. So now I got my slope. Now I got my D value. Now I can find A. Okay. So always do this guy first. And if I want to find A, this is where I usually use my A sub n formula. Okay. Now, somebody might say, well, can't I just take this negative 10 and start on the 8th term and then go backwards and add 10 and add 10? And yes, you could do that. Okay. There's nothing wrong with that, I guess, but what are you going to do if you have the 100th term and the 200th term? Are you going to do that 100 times? I hope not. So you could use either one of this bit of information. You can use the 8th term as 4 or the 18th term as negative 96. I'm going to go ahead and just use the first term. The 8th term is 4. So the 4th is that term. I'm looking for A, the first term. N is what term it is. That's 8 minus 1. And then your common difference. This is where if you don't have the common difference, you couldn't go any further because you would have two unknowns. So we got 4 equals A plus 8 minus 1 times negative 10. And we do a little simplifying. 8 minus 1 is 7. 7 times negative 10, I'll write up here. I got negative, so I got 4 equals A minus 70. And now I can add the 70 over. So 4 plus 70, we get 74. Okay, so that's my first term, that's 74. And then we got our D value, okay? Now my MATLAB is going to ask you to put in the recursive formula, and that looks something like this, where it's A sub n equals A sub n minus 1 and then plus D. So they'll probably have this area where you need to fill in the D value, essentially. Okay, so that's what this would look like. A sub n equals A sub n minus 1, the term in front of it, and then plus or minus, in the case, minus 10. That's your recursive formula right there. You have your A value, your D value, good to go. Okay, do we have any questions?
Move it up.
Move it up?
Yes, please, just real quick.
Like this? Or move it down?
No, that's good, thank you.
Yep. I will come back and do example 8 on Thursday. I just want to make sure we get one of the sum questions done so you guys have some stuff to work on over the next few days. If you need to see number 8 worked out, I do have it worked out online already for you guys. All right, but we can come back Thursday and take questions and stuff. Hopefully, people will ask questions. Right? All right, let's finish up. We're just going to do number 9 real quick. And this will help us as we're going through 39 through 56. They say find the sum of the first n terms of a sequence. Understand if I have a sequence, right, that's arithmetic, one easy way that I can do to find the sum is take the first and last numbers and add them together and divide by 2, and that gives me my average. If I take that average and then multiply by how many terms I have, that is the sum of my sequence. So again, first and last number, add them together, divide by 2 average. Okay, that's represented here, A plus A sub n. Divided by 2, that's the average, and then multiply by how many terms you have, and that gives you your total sum. Well, that's essentially represented here as well, but if you don't know A sub n, then you can use this formula where it's A plus n minus 1 times D, where A plus A ends up to be 2A. So remember, A sub n is A plus n minus 1 times D. So the one we use a lot is this one. On the word problems, I would probably use this one because they don't usually tell you how many are in the last. So WP is word problems. How many are in the last row? So as I take a look, we have A and we have A sub n. We have A and A sub n here. So this is the one I'm going to use. I'm going to use this sum. And it's pretty easy. All you got to do is plug and chug and understand if your last term has an n in it, then your answer is going to have an n in it. Okay? So if I take a look, if I want to find the sum, n is n, a is my first term, which is 8, and a sub n is 3n plus 5. I do a little simplifying. 8 plus 5 is 13. And then I would probably go a little bit further by distributing the n. N times 3n is 3n squared, and n times 13 is 13n. And then you could divide everything by 2 or just write the whole thing over 2 as well. It's kind of your choice on what you want to do. And that is my sum formula for this sequence. And now this would allow me to find the sum of as many terms as I want to find. So if I wanted to find the sum of the first 2 terms, I could plug in 2, because it's the first 2 terms. And if I plug in 2 here and here and add them together, I will get 19, which is 8 plus 11. If I want to find the sum of the first 3 terms, plug in 3 and plug it here and here and simplify it, and I'll get whatever 8 plus 11 plus 14 is, which is what, 33. Okay? So this is a formula that allows me to find the sum of as many terms of this sequence. Okay? All right, so we're moving on. We take a look at number 10, and we got our first term and we have our last term. So again, I'm going to use this formula here. So I've got S sub n equals n over 2, and I got a plus a sub n. I plug in those numbers. I don't know what term this is. I don't know what n is, and that's where we're going to have to figure that out. I do know what a is. A is 8, and I know a sub n is 50. Okay? So this is where I'm at. I've got n over 2 times 58. The problem I have now is I don't know what term this is. I don't know n. So that's where I have to either look at my sequence and figure out how much I'm going up by and what term that is. So keep on adding, in this case, 3 every time to see how long it takes me to get up to 50. Or a better idea is use your a sub n formula. So use a sub n equals a plus n minus 1 times d. We know that's the 50th. Well, that's our 50. We just don't know what term that is. You know, a is 8. And we're trying to find this guy right here. We know d, or common difference, is 3. So I do a little math magic here. I go ahead and subtract 8 over. I get 42 equals 3 times n minus 1, or n minus 1 times 3. I would probably just divide by 3 here. So we get 42 divided by 3 is 14, and then that equals n minus 1. These guys cancel, and we can add the 1. So we get n is 15. So now I can plug that in, plug in 15 here, and I do a little math magic. So I got 15 divided by 2, press enter, and then I got times 58. So final answer, the sum of the first 15 terms I get is 435. Boom. Look at that. So again, if you have a number here, you should get a number for your answer. If this has an n in it, your answer for sum is going to have an n in it. So easy peasy lemon squeezy. All right. So last but not least, ladies and gentlemen, we got 11 and 12. I've shown you how to do number 11 already using summation. So I'm going to go ahead and type that in like we see it. All right, so you TI-84 people, we're going to type it in. We got math menu. We have the summation down there at 0. and we're going to type in x instead of n. We got starts at 1, and it goes all the way to 20. And then my sequence is 3n plus 5, so I'm going to go 3x plus 5 this time. I'm going to press enter, and then it does it all for me. So final answer I get is 730. Okay, so final answer for our sum. If I have a TI-83, this is where I got to go sum of the sequence. Okay, and that will be my sequence of 3x plus 5. I got to define my variable, comma, x. So define my variable x, comma, where do I start and where do I finish? And just a reminder where to find sum and sequence for my TI-83 people. We go second stat, we go over to math. There's the sum. So we would press enter on that, and then second stat list ops sequence. So that's where you find the sum of the sequence for those, for your TI-83 people. Okay, and then you guys can type that in. So either way, you should get 730 there. All right. So last but not least, number 12. How do I do number 12 in my calculator? Well, the idea is I'm going to use my little sigma notation. All right. I'm going to assume that this is the first term, so I'm going to start at 1. And I got to know what term this is. All right, so I need to know where I finish at. I got to know what's n. Well, that's where I could use my formula here. All right, and I know I'm finishing at the 15th term. Okay. Well, here I need to know what a sub n is. I got to know what's my sequence if I'm using my calculator like this. Okay, so that's where I would go off to the side and I go, okay, a sub n equals a plus n minus 1 times d. And then I go, okay, a, my first term is 8, n is n, and my difference, this thing keeps going up by 3. So I distribute, and I simplify, and I get 3n, and then plus 5. So my sequence that I have here is 3n plus 5. Okay? And then, that's where you could use that, and if you didn't already know this value, well, now I can plug in 50, and then subtract the 5, that's 45, and then divide by 3, and that's where I get 15 from. So now I know that's 15. So you guys are going to have to find out this value, and you're going to have to find out this guy right here. You're going to have to find a sub n, you're going to have to find n, what term you're going to. And that's where you would use your calculator now. Like I just showed you, math menu. I go all the way down to summation. And now I know I'm using, instead of n's, x's, x equals 1. I'm going to the 15th term, and I'm doing, in this case, 3x plus 5. Okay, and I get my final answer, which is 435. Okay, and now you can see that is the exact same answer that we got up here. It's the exact same question. This is how you would do it by hand, and this is how you would have to use your calculator. The tough thing is they didn't give you this in terms of n, so you have to find that. And you also have to know what term that is. So this one's a little bit trickier because you got to know those two things. You got to know what n is, you got to know what a sub n is. Okay? So ladies and gentlemen, that is a long day of notes for chapter 12.2, and that's why we break it into 2 parts, but now you have it all in one. Have a great day.